Okay? You can say hello now.
Hello.
Okay, sit down, sit down.
Whoa.
Sit down, sit down. Okay, hello.
Babe.
Sit down, sit down.
Gotcha.
Sit down.
Ooh.
Hello, Eric. Hello, Ryan.
Hello.
Sit down, please.
I'm bad.
So today we're going to talk another. Remember yesterday we talked about the quick sort, right? And today.
I talked about something else.
Yeah. That's okay. It's okay. Today. We're going to learn about MergeSort.
MergeSort. Like important random. This is it.
Yeah. Can you tell me what is MergeSort? You know what do you think it's by MergeSort? Okay. Do you still remember a few days ago we talked about how to merge two sorted lists? Remember?
Yeah.
Yeah. Look at it. Look at it. Yeah. And a list 1, 2. Yeah.
Yeah.
Another list maybe 1, 3. Another list 2, 4. When you merge it, so what we get?
1, 2, 3, 4.
Yeah, that's easy. Yeah.
Easy peasy.
Remember we talk if these two are sorted. Yeah. Both lists. Yeah, both lists are sorted, then we can compare, right? The small list. Yeah? Now left hand is small list, so it's 1, yeah? And then move here. Is 2 smaller than 3? Yes, then 2 here, and then move here. 3, 4. You see?
I don't understand
Yeah.
how you get it.
Yeah, okay, so
I
this is
understand how you get it.
get what? The merge sort?
Yeah.
Okay,
It's easy, babe.
okay, I show you again, okay? Okay, maybe Eric, yeah? Eric, you want to teach Ryan?
How can I, babe?
Okay, Ryan, you look. Look, if it's the number 1, 3, 5, right? Another list is 2, 4, 6. These two lists are sorted. They are in order, right? 1 smaller than 3, 5, yeah?
1.
And 2, 4, 6 are increasing, yeah? So what we do is that left hand, right hand. Then we compare the value of left hand and right hand. Is 1 smaller than 2?
Yeah.
Okay, so if smaller 1 and 2, then I picked 1. I push it into put the 1 here, yeah? And then move it here.
Yes.
Move the left hand here. And if 2 and smaller than 3, yes? Yes? 2 smaller than 3. Then we push the 2 here, right? Ryan?
Yes.
Yes? Do you get it? Can you go there, please? Do you get it? 2 and 3, 2 smaller, right? And I put it 2 here, then I move here. And 3 and 4, 3 smaller, right? Yes?
Yeah.
Then I put the 3 here, and I move the 3, move the left hand here. And then 5 and 4, 4 is smaller, yeah? And then move it here. Yeah, and 5 and 6, yeah, 5 and 6, and then that's 5, and then that's 6. Do you get it? So if there are two sorted lists, I can do this by O and M, right? This is OAP, right? If this is A, this is B, then the complexity is OA plus B, okay? Yeah, this is the review of the merging two sorted lists. Can we sit down, please? Please, what did we talk about? How to be a good boy during the class?
Doing lesson.
Yeah, playing.
Yeah, they want to make it funny.
No, that's enough. You're playing all the time. Okay, sit down. Now,
We're supposed to.
now, listen to me. So how does that help? Look, if we know two lists are already sorted, then we can do this way, right? Then we can. So our task is to divide a list and all the list into a small pieces and then merge it back. Look, if this is a list, right? Look, if 2, 4, 5, 6, 1, and 3, okay? If there are 6 numbers, am I right? Ryan, sit down. If there are 6 numbers, wait.
Yes, I am looking.
You are looking, okay? If there are 6
I
numbers,
know.
okay, now we want to sort this, make this sorted.
Yeah, that would be easy.
So how do we do this? We first
1, 2, 3, 4, 5, 6.
yes, by computer we can do this. Look, we can divide this into 2, right? Yeah, 2 equal part, yeah? Yeah, 2 equal part. Then we sort this. If we can make this sorted and make this sorted, then we can use, remember, the merge function. Yeah? Remember with the merge function. Yeah? To merge these two parts, right? Yeah? Yes? So in order to solve this, we partition this into half, right? Okay? Do you get it? Okay? We partition this into half. So it could be.
That's 3 pieces.
Yeah, I know. It could be. You can put it this way. It doesn't have to, because 3 numbers it cannot equally be 2 parts. But how about it? Let's do it this way. Okay? Do it this way. Okay? Now this one number is already sorted. Yeah. We don't need to sort it. Now we want to make this sorted. Yeah.
2, 4 already sorted.
But we don't. But we have to put it into 2 pieces. Now 2 is sorted. 4 is sorted. Am I right? So then I use this to merge this into 2, right? Yeah, then 2, 4 are sorted. And 2, 4 are sorted, and 5 merge it.
No.
Sorted. Do you get it?
1 and 3 are not sorted.
Don't worry. When this is sorted, when this bit sorted is 1, 3, 6. Yeah, right? And 1, 3, 6, and 2, 4, 5 merge it. Remember the merge function? Yes? Remember we talked about that and then we can merge it. Do you see the point?
Yeah.
Okay, another example. Ryan, are you listening? Erin, that's enough, okay? Daddy is talking, okay, please.
Yeah.
Ryan,
Whoa.
okay, look.
Yeah.
Another one, okay? MergeSort, okay? MergeSort, we are talking about MergeSort.
Yeah.
So the first, so look, 3, 2, 1, 6. How do we solve these 4 numbers? Easy.
1, 2, 3, 6.
I know. How do we solve it, computer? Look, first of all, divide it into 2 pieces, yeah?
2, 1, 6.
And then these 2 pieces again,
2, 3, 1, 6.
put it into half. So these 4 pieces are already sorted by their own, right? If we merge these 2, we have 2, 3. If we merge these 2, there will be 1, 6. And how about we merge 2, 3 and 1, 6, then it will become 1, 2, 3, 6. So you see how we get it? We divide and solve each part, yeah? Divide and solve each part. Divide and conquer, right? So you see it? Divide and conquer, okay? So let's write the code, okay? So let's write the code.
The code is important.
Okay, wait. So you help me, okay? I write it and then you can tell me, okay? First of all, let's skip the first page, which is the merge to list, okay? Or we can come up later. Like, come here. Define merge, okay? Merge. If we want to merge two lists, A and B, yeah? A and B. What am I missing here?
Colon.
Okay.
Yeah, babe.
Okay, now if
I, J, L, A, L,
I
B is the same as 0, 0.
Ryan. Okay, look, this merge is merge two lists here. If we are taking a parameter merge array, we are merging array. Okay, so let us start with this bit first. If we merge this array, merge sort this array. Okay, so to make it simple, so merge sort to sort, merge sort.
Merge sort.
Okay, so now we need to check if the length, yeah, if it's smaller than equal than 1. If it's nothing, if the element is nothing, empty, or it's one element, it's already sorted, right? Am I right? It's already sorted.
What's ARR?
AR is this. AR. Okay?
What's ARR?
Array. So we return array, right? If it's already one element, we return it, right? Okay, so now we need to find the middle part, right? Look, we need to find the middle part to split, partition the list into 2 halves, right? Yes? So now we calculate the middle half equals length. This is length, and divided by 2, right?
Yeah.
Divided by 2. Okay, now the first half, the left half, look, now we have an array. This is an array, yeah? And we have calculated the middle part, yeah? And then we want to solve this. Anyway, can you look at Daddy, please? You want to? But you're working. Can you sit down and look at me, okay?
You already know.
Okay, you already know. The left part and the right part. Okay, what am I writing now? You already know.
Yeah.
Okay, so left. Now the left part equals this ARR. We are doing it until the mid, right? Yeah. So now this is the left is this part, yeah. This is left.
Left and that's right.
Right. So
Right.
right is what? ARR
Bracket.
mid
Mid.
column. It means starts from mid and then this part, okay? And now we have the right part, left part. What we are doing now? We call the MergeSort functions to sort these two parts, right? So we are calling these two functions, right? Left equals that, right equals that. Then we need to sort. MergeSort. MergeSort
ARR.
left, because we are sorting the left bit and we assign it to. We can assign it to left as well. And right equals MergeSort right.
Oh.
Right? So now these two bits are already in order. Now what we need to do is to merge it.
MergeSort 1, 3,
Merge
2,
it.
4,
No, you
5,
can.
7, 6, 8, minus 1, 9, 10,
Merge
12, 17,
left and right, right? Okay, so you get it? Do you get it?
Yes.
Yeah, do you get it?
That's 1.
Do you get it? Look. So Eric.
Still be the same thing.
Eric.
Here.
Yeah, Eric, look. So look, Eric. If it is an array, right? It's a list, a number, a few numbers.
Okay, it's like this.
Yeah. No. Look at that. Eric, listen. Ryan, listen. Okay.
Oh yeah.
Okay, listen. Do you get me? Look, a list. So I want to sort a list, a few numbers. So first step, divide it into half.
Yeah.
And then I sort these two bits. Once these are sorted, I merge it. Yeah.
See, big brain, another big brain here.
So until and we recursively and dividing, partitioning the array into smaller bits until it becomes only one element or nothing. Yeah. When it's only one element, it's already sorted, right? I give you a number, I say it's sorted. Am I right? It is, right? Yes. If I give you a number 3, I say is it sorted?
Yes.
Yes, of course. It's not one number. It's sorted. It's in the right place. If it's sorted, and then if we have two, otherwise when we have this already sorted part, if this one number is sorted, yeah, and this number is sorted, then what we do? We merge it. Remember, we know how to merge two sorted lists, right? We know this.
I'm merging.
Yeah, merging. Yeah.
Merging.
So when you merge it, you can merge it into a bigger part. Am I right?
Whoa.
Okay. So now, let's review how to.
Another big brain here.
Look, Eric. We are calling the merge here, which is not implement here, right?
Yeah, merge.
This is the important part. Merge 1, 2 into 1, 2, right?
Yes.
Okay, let's write this merge. Let's review it. We know how to do this a few days ago, right? Let's write it again, okay? Look, and you correct me if I'm wrong, okay? Merge. Merge A, B, column, yeah?
I didn't do that.
Yeah, merge A, B. Then what? We need to get the I, J pointing to the beginning of both, yeah?
What are we doing?
Merge two sorted lists, remember?
No,
Yeah.
I don't.
Merge two sorted lists. IJ, LA, LB equals 0, 0, length LA, length B, right? So this is just two sorted lists, yeah? Two sorted lists. 1, 3, 5, 2, 4, 6, and we want to put this into 1, 2, 3, 4, 5, 6, yes? Okay? Now, Y, I smaller than what? Y I smaller than what?
I smaller than
L, and what?
Not touching this.
And what?
Not touching this.
And J smaller than LB, yeah? Why these two pointers are not reaching the end? Then we need to compare. If AI is smaller than bj, right?
Don't keep looking.
That's okay. Sit down. If one element is smaller than the other one, yeah, then I pick the smaller one, right?
Yeah.
Smaller one. Let's put the result here. Result here. Then result dot append ai as result dot append bj, right? And then you need to plus equals 1. Move the pointer to the forward, yeah? Move the smaller pointer to the bigger one, okay? And then, what's next? And what's next? When one reaches the end, the other may not finish, right? So we need to compare the size. If I smaller than LA, then we append, we can plus equals the next, yeah, which is it means from the current position to the end, as res plus equal bj, yeah, and then return result, yeah. Got it? Alright? Yeah, you see how this is beautiful algorithm, right? So the complexity is O n log n, similar to quicksort. Remember we talked about quicksort yesterday, yeah? It's the similar complexity. Okay, any questions?
No.
Okay, so do you want to say goodbye?
Bye! Oh, you